So how do you solve a circuit when you have a voltage source in between two of your nodes? Can you use simple node voltage? And the answer is no. And it's because you don't actually know what kind of current is running through here. So this is why we need a supernode. And if you haven't checked out my nodal analysis video, click up there, give it a watch. All right, so what is a supernode? A supernode is anytime you have one of these voltage sources in between two of your nodes. So this really throws our KCLs to the trash. So what we need to do is instead of doing KCL to V1 and KCLs for V2, we're going to do a KCL for a supernode. So first, let's draw around our supernode. So this dashed line is going to be the supernode. Now we're going to use KCL, just one KCL equation, going to the supernode. Also, we have two nodes, V1 and V2. And ultimately, our goal is to find their values. So we have two nodes. We're going to need our two equations, even though there's three nodes, because that's technically V3. So three total nodes, two equations needed, knowing that's 0 volts. And we're going to use a supernode equation. So what's our supernode equation? Well, we're going to use these values and the fact that we know the voltage between them. We can see here, we got positive here, negative there. We're going to do V1 minus V2 is going to have a difference of 6 volts. So V1 minus V2 equals 6 volts. Let's rearrange that a little bit. Now we have V1 equals 6 volts plus V2. So there's equation 1. Now we're just going to do a single KCL equation. So we can already see we have 6 milliamps going to it. We have 4 milliamps going away. Because this is V1, we're going to call this I1. Because this is V2, we'll call it I2. Now we're going to do our supernode KCL. Remember, currents going to your node are positive, currents going away from the node, negative. So 0 will equal 6 milliamps minus 4 milliamps minus I1 minus I2. We can already simplify this, and now we can move 2 milliamps on the other side. So that will be negative 2 milliamps equals negative I1 minus I2. So we're going to multiply everybody by negative 1 at the same time, and you'll see we now have 2 milliamps equals I1 plus I2. Now, basically, we're in business. We just need to fill in the values for I1 and I2 and solve our two equations. So what does I1 equal? Well, I1 is going to be the current going through the 6 kilo ohm resistor. So Ohm's law will be V1 over 6k ohm will equal I1. What about I2? That's the current going through this 12k ohm resistor. So V2 over 12k ohm will equal I2. Now let's put that into our equation. Let's make the denominators equal by doubling V1 in the 6k ohm. Let's get rid of the 12k ohm in the denominator by multiplying everybody by 12k ohm. So that will distribute everywhere. So 12k ohm times 2 milliamps is, of course, 24 volts. And then for this side of the equation, we can just get rid of the 12k ohm denominators like so, because obviously they'll just cancel out. So we're left with 24 volts equals 2V1 plus V2. Now we already have up here from our supernode equation, V1 equals 6 volts plus V2. So let's plug it into our equation down here. And now we just solve. So we distribute the 2. So 2 times 6 volts is 12 volts. 2 times V2 is 2V2. And we can't forget about our plus V2 over here. So now we simplify. Let's take our 12 volts to the left. And then we're going to combine 2V2 and V2. Then 12 volts divided by 3, of course, is 4. So there's one node voltage. Now we're going to plug it back in to our supernode equation as well. So now we have V1 equals 6 volts plus 4 volts, and of course, V1 equals 10 volts. So the big takeaway of this, whenever you see a supernode, enclose it in its own thing, use this as your first equation, then do KCL to the whole node. Don't do KCL for V1 and KCL for V2, KCL for the whole node. If you do those two steps, it's the exact same as any other problem. I hope that helps. Have a good day.